Good morning all. I like constructional toys, and one of my favourites is Knex. This system where you take these connectors and rods and you clip the rods into the connectors and make geometrical shapes, and far more than geometrical shapes, of course. You can make models, cars and cranes and all sorts of things like that, but this is basically how it works, like that. And so what I've been doing this morning is building myself a big tower, and it is quite big. It starts off with the grey rods at the bottom, comes up to the red section, then up to the yellow section, then it moves up to the blue section, and it actually goes all the way up within 1 inch of the ceiling. So this thing is tall. I mean, it has to be, well, about 8 foot tall, I'd have said. Thing is though, is it 8 foot tall? The thing that's been bothering me over the last few days is, what is Knex's fundamental unit of measurement? I mean, when the guys sat down and said, let's design a constructional toy, how did they size it? Now, Knex is an American invention, invented by Joel Glickman, introduced to the US in 1992, produced by Knex Industries of Hatfield, Pennsylvania. So you'd imagine that all the sizing would be done in inches, and that's why I described my tower as being 8 foot tall. But there's nothing on Wikipedia, or in fact the company's own website, that indicates how large the parts are, what dimensions are used for the various pieces of Knex. So I'm going to have to measure them. Okay, let's start with the rods. Well, the green is not anything recognisable on the inch scale. White is just over 1.25 inches. Blue is 2 inches and 1/8. Yellow isn't anything, it's 3 3/8. Red is almost 5 inches, but it's not quite. It's a little bit more. And the grey rod is just over 7.5 inches, so none of those come to an exact number. The width of the connector is actually a bit more promising. That's almost exactly 1.5 inches. It's a little bit short, but not far out. So is that it? Is it 1.5 inches? Now, of course, I'm measuring the wrong thing here. I should be measuring the distance between the centres of the connector pieces, because of the way that Knex is all based on triangles. Let's put these pieces together. And more specifically, it's based on right angle triangles. And even more specifically than that, it's based on isosceles right angle triangles. So because Knex uses a connector piece with 8 holes in it, 8 spokes, then these connection points are 45 degrees apart from each other, which means that this angle here is a right angle, and therefore this length here between the centres is √2 times this length between the centres on the shorter rod. Now let's take this as 1. That's a unit distance of 1 between these two centre holes. That's also 1. We know from Pythagoras that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So 1 squared is 1 plus 1 squared is another 1, so that makes 2. So the square on the hypotenuse is 2, so the hypotenuse is the square root of 2. So perhaps this here is the fundamental unit of measurement of Knex, this distance between the two centres here. Let's take a look at what that distance is. And it's not far off 1.5 inches, which is the same as the width of the connector itself, of course, because these two connectors are virtually touching. So is that it? Is it 1.5 inches? Now we'll get a better measurement if we go to a larger gap. And if this is a unit, 1, and this is 1, then this hypotenuse, the diagonal, is 1.414. That's the square root of 2. If I turn this round though and take this as 1, then this is 1.414 times the length of the white spoke. So actually the blue spoke center to center is twice the distance of the green spoke center to center. So I can get a more accurate measurement by measuring the distance between these two holes turned around 90 degrees. Let's see if that's 3 inches. It should be. Okay, so that's bang on the center there. Well, it's not quite, is it? It's not 3 inches. It's slightly, I've got to check for parallax. It's slightly less than 3 inches. So what's going on here? Let's actually go to the red center to center, which will give me twice that again, so 6 inches. So here's the measurement for red center to center, and no, it's not 6 inches. It's actually quite a bit short of 6 inches. So what's going on here? Is this thing measured in inches at all? Or is it, horror of horrors, metric? So let's come back to this shortest distance measurement with the green rod. Now what's that? That's, well, it's about 37 and a half. Oh, 37 and a half. That sounds worryingly like half of something a bit more of a round number. Let's come to this one. Oh, that's 75, look. That's exactly, or almost exactly 75 millimeters. So this one, the red one, is going to be, let me get that absolutely on, trying to adjust for parallax as I go. Let's get that under the lens. Well, it's pretty close to 150 millimeters. In fact, it's almost exactly 150 millimeters. It's so close that any error could be down to really the ruler, not the Knex itself. So am I seeing that Knex is actually measured in metric units and not inches? That's horrendous. Why would an all-American toy be sized with metric units? Why isn't it in inches? That's very surprising. And so I have to conclude that my tower isn't 8 foot tall at all. It's actually 2.4 meters tall. So it would seem that Knex, the all-American construction toy, is actually sized in metric units, which is very surprising. I was expecting to find, I don't know, 4 inches or 6 inches or something good and imperial like that. Incidentally, when you're taking Knex apart, don't bend the rods like that because that damages the plastic. You have to push them apart sideways, laterally, like that. And that doesn't damage the plastic. So there it is, Knex, one of my favourite toys. Cheerio.